Welcome to the brief presentation on the latest South Me Plus. So this is the latest GNSS receiver from South. It's got the built-in visual lidar using SLAM. So there's many ways you can deploy it in the field. It's shown here as a handheld unit with a little base plate with a cross on it. So you can just walk around the site holding it indoors, outdoors, and it's just going to map everything around you. If you're outdoors, it can use the built-in GNSS and position your data as you're walking around on your local survey coordinate system. So, and then of course it's got, it can be pole mounted. So you don't have to hand hold it like that. You could stick it on a survey pole and operate it as a traditional GNSS, or even more powerful, use the mixed solution where you can go and use the combined lidar and the GNSS to let you go and survey areas that are not very good for GNSS surveys, like under trees or under the eaves of buildings and stuff like that. One of the powerful features of the new Me Plus is it's got a built-in UHF radio, so you can use it with your own RTK GNSS base station on your site. So that lets you work in more remote locations than previous models. So we'll just have a look at the data that we're getting out of it. So I'm just showing you some sample point clouds in the Autodesk Recap software. So this is a free plugin by Autodesk. So if you're using, I don't know, Autodesk 3D, Inventor, Revit, those types of Autodesk products, you can bring in these 3D point clouds and they'll look and perform just like I'm showing you in the video. So here we've got a small data set here just collected in a few minutes of some trees. So you can see it's we've just sort of walked around where my cursor's sort of being moved, but you can see it captures trees way beyond where we're standing and walking. So you can see the level of detail that you can get off the data. So if you just maybe cut out of some of the stuff. You can just maybe just cut a small slice through here. So you can see here's one of the stems here. So you can see the stem of a tree is pretty, well, maybe we just change our view more perpendicular up and down. So you can see there's another stem here. So you can see the stems are, as all tree trunks are, they're not perfectly circular. So, you can go and measure not just the heights, but, the diameters. So, yeah, so the collection time was a few minutes, the time it took to do a little circular path over the work area. So this particular stem here, we've got a little paint mark indicating, breast height there, diameter breast height. So that's of some tree spaces there. If we just go and open up another data set. So we've got a section of road here that was sort of scanned from here up to the top there. Give you an idea of scale, size. So, 438 meters, so it's a sizable sort of an area. So this data set was collected in a single scan that took about 20 minutes at a very slow walking pace. And you can see the level of detail that you can really get down to. This is in Tauranga at the race courses there where the entranceway is. So we sort of just walked on a zigzag path down through the trees and the road there in the 20 minutes that we had. So it would be pretty difficult to go and measure this work area with the GNSS on its own or with a robotic total station because it's a pretty sizable area. So that's the sort of level of detail and the size of an area that you can cover in just 20 minutes. So you can cover a lot of area in a very short amount of time. So we'll just move on to another quick data set. So we've just got a tiny data set here measured inside a building. So we can do the same thing. We can start to clip out work areas, have a look at stuff. So again, it's just the length of time it takes you to walk through the work area. And we can, again, take a little slice. So I've just done a little slice here. So you can see the thickness on the walls here. Try and render it a bit. So we can go and check some of the wall thicknesses. So you can see 102 mils there, 105 mils there. It's just a typical wall thickness. So of course, you can take this data into this, like I said, all the Autodesk products and other third-party CAD packages and do your traditional CAD designing and modeling and so on. So anyway, that's just a very brief overview from me. If you have any further questions, feel free to contact us on our website. There's all the contact details there if you have any questions. So thank you very much for listening.